systems in Naman, how to build free. That easy we put instrumentation. Is the intention. To sequential only they are having. So only 3 students, I think. Okay, Ganesh, Ritik, and one more. I am not able to see the name. I mean, for EC is only 3. Okay, what I will do is see here. Good evening, Amtav ji. Okay, listen. Himasri, right? Okay. Okay, today first 1 hour. Okay, previous chapters. Second 1 hour, logic families for ECB. Okay, so this is what we are going to plan for. So first 1 hour, let's start. So let me start with a very good question. Right, let's do this question. I will start the board. So these are your options. So let's start. Let's start the poll. Just read it. I will start the poll if you are ready. Good evening, Rahul. So trap में फंस गया 72%, 8%, 8%, right? Finally, only 12% तो right answer दिया. Okay, right. So intentionally, I changed the option such that you will definitely keep this as the right answer. This is not right answer. This is the right answer. Okay, let me explain. Let me explain. What is the total conversion time? What is the time required for conversion? 200 microseconds. So the sampling time should be greater than 200 microseconds. Okay. The frequency of sampling should be less than 1 by 200 microseconds. So the frequency of sampling must be less than 5 kilohertz. I hope most of you have done up to this correctly, right? The frequency of the sampling, that is the sample frequency or the time gap between two successive samples, this much. Okay. So the how frequent you can take the samples is 5 kilohertz, 5 kilo per thousand. Okay, but the question is not to find the frequency of sampling. What is the highest frequency? That is the analog input should be allowed. He asked very good answer. Nyquist criteria. In exam, actually options my 5 is not there. Then anybody can answer it. But if I keep 5, then you will get confused. Then easily trapped into this. So here he asked analog signal, not sampling frequency. It is the signal input signal frequency. So you know FM must be less than or equal to Fs by 2. That is by Nyquist. Yes, Amitabh ji. By Nyquist, FM, the analog signal frequency must be less than Fs by 2. So what is the FM here we are having? Should be less than or equal to 5k by 2. That is 2.5 kilo. Understand? How is the trap? What is Nyquist? I cannot say Mohan. No, Nyquist criteria is the when your analog signal is being sampled into digital signal. That is, see here. Let me explain you a little fastly. This is the analog signal. You are sampling this. When you are sampling this, according to Nyquist criteria, the frequency of these successive samples, what we call the frequency of the sampling, should be minimum greater than 2 times the analog signal. Then only the signal can be reconstructed properly. Okay, this you will study in your signals and systems and communications also. This is not our part, you should know it. Okay, Ganesh. Next question. It's a simple question, right? If you want, I can zoom the figure, first read it. Yeah, you can say that. That is, this can be avoided if what we call Fs is greater than 2F. Okay, read this part, figure I will come, figure I will explain. I will zoom if you want. Are you ready? What happened here? No comments are coming. You people are there or not? Any issue? You are there. Okay, I am happy. So read the question. The circuit shown in the figure represents the counter-based unipolar ADC. When SOC is accepted, the counter is reset and clock is enabled so that the counter counts up. The DSC output grows. When the comparator switches from logic 0 to logic 1, whatever may be the story, what he wants. The maximum error in the conversion of the analog sample is proportional to. Ready? So let's start the poll. Good. You can see the poll board. Good. Only 4 people are 2 by 3. Anyway, one question can be removed as a EC triplet case. Okay. So now it is a very simple. Don't worry about this figure also, even it is not required for you. Okay. Actually, this buffer is used to whenever end of the conversion comes, then output will be read. That will to do that you can use that. That is not required. So what is the maximum error we are having? What is the maximum error? Is equal to 1 step size. इसमें trap कुछ नहीं. Okay, no trap is there in this. Maximum error is equal to step size. Right? So maximum error is equal to step size, which is V reference by 2 to the power of n minus 1. So your error is proportional to V reference, inversely proportional to 2 power n. That is n, you can say. So n increase हुआ तो your error decrease. Reference increased, but n is not increased, then error will increase. So what is the answer? Is it directly proportional to V reference? Correct or not? Right. Yes. Logic work. Ready. Yes. Step says LSB resolution all are same. Read this question. I'll make the poll. I mean, I will connect the poll, but meanwhile, first read. I need pen to calculate this. Let's do the calculate. Let me do the calculation. Okay, right, correct, Ruchita. So options are 1 milliampere, option B 10 milliampere, option C 100 milliampere. Try this. If you're ready, I will start the poll. Okay, good. Okay, very good. Most of you have given right answer only. There is no difficulty in this. So let's do it. Examiner has given 3-bit binary counter shown in the figure. The counter increments on every positive clock. Okay. Uh, they assume that ideal diodes that are starting from 000. If the output is high is equal to 1 volt, low is equal to 0 volt, the current in milliamperes through the 50 ohm resistor is. If it is high, you get 1 volt. If it is low, you will get 0 volts. Okay. He said the diode is what is that? Diodes are ideal. Okay. So when you give 101 here, okay, 101 here. This diode will be forward biased. This also forward biased. This will be forward biased because it is a cathode. So it will be ground. So now listen here. So for this, what to do? It is equal to, this is your circuit. It is a 1 volt series with resistance of 100, in series with 1 volt parallel with the series with a resistance of 100, and this is 50, and this is ground. You understand, this circuit can be replaced by this for 101. So what to do? You replace this with its milliamps equivalent. It will become 1 and 50. What is milliamps equivalent, sir? Formula I am giving you: V dash equal to V1 G1 plus V2 G2 by G1 plus G2. Okay. Similarly, what is R dash is 1 by G1 plus G2. These are the formulas. So using that, you can replace this will come out to be 50, and this will come out to be 1. So you can replace this with 1 volt series with 50. Okay, and for that you have connected one resistor of 50 ohms. Okay, you need to find this current I. What is current I? 1 by 100, which is 10 milliampere. That much simple question, not a difficult. Some networks part is there in the question. Shall I move further? Is it okay for everybody? Good. So let's take one more question. Let me upload the question and give me 1 minute. Okay. So I'm sorry, actually I'm not able, forgot to upload this. So I'm searching for the questions. Yes. Okay, do this. Some previous question. So you are having a resolution of 4-bit, counting ADC is 0.5. For the analog input 6, what is the digital output? Yes, Pola. Good. So let's do it. It's not a big issue. This is point. So what is the ceiling function of 6 points? Because he said counting type ADC. Ceiling function of this by this. What is the answer? 14. So it will be simple step. Ceiling function, Archa, 13 point something will come. You should take it as 14 only. For counter type, I already told you that. So the next question is getting uploaded. Yeah, you must see. That's why I have given that question. Oh, maybe he's saying pole R. You want pole R. Why question is not uploading? Oh, yeah, some small issue is there. It will upload. Just wait. I start the board. Why some people are giving wrong for this question also? Not right. So what is the answer here? Simple answer. Whatever you get this here, this is what we call, what is the name of it? Step size. What is the analog output? Is equal to resolution. What is the resolution? 0.0625 into decimal equivalent 50. There is nothing difficult in this question. Power issue is there. Am I visible, audible? I'm audible, right? So let's do the next question. The question. Okay, get ready. I will start. answer may be right or wrong. I kept you in suspense again. Okay, just wait. Listen. Yes, firstly see here. What are the mistakes in each step? Here, 2R. What is the design? It should be 2R, 2R, R, 2R, R, 2R. This is the method you should go. So here this should be 2R. Okay. So this is not the right figure. This is not the right figure. So structure is same here. In these two structures, which one is the right answer? In these two structures, which one is the right answer is closest here, closest to this ground should be LSB. And this should be MSB, which is close to the op amp. So that according to that, this is the right answer, which we discussed in the class already. Only this can be correct. Okay, right. Now, I forgot to give you corrections from the quiz. Let me give you those two corrections. I hope first question this one. Quiz corrections. What is the first question is determine required. Okay. 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 If you get a b bar to y and this is equal to x. X means what? A greater than b. A less than b. This story. Okay. Now, what is the answer here for? I gave 5 by taking conventional figure. That is wrong. And similarly, number of what is that? Half adders required to binary is not. I'm sorry for that. Okay, it is some story. I mean, some figure we have discussed earlier also, and you have something here, and you get some gate, and some this kind of circuit you will be having 4-bit adder, and this is 4-bit 7. Answer is 14. This is wrong analysis. Here, this is wrong. 14 is not the right answer. Okay. 14 is not the right answer. Why 14 is not the right answer, sir? I will explain it. You understand this logic? This figure we discussed already, right? Okay. Now I want to prove, I want to explain you what is the best way to do this without having taking it as a 14. Let's do it. You have 4-bit number B3, B2, B1, B0. Here A3, A2, A1, A0. Here C0 equal to 0. So it is a 4-bit parallel adder, binary adder. So which will have this circuit. S3, okay, carry. So now this I have already explained you. What is the logic? S3 into, yeah, this is the circuit now. S3 into S2, S1 into S0. Is this not correct? So I will believe in you. S3 into S2, S3 into S1. So okay. So see here, this is by default 0. This is by default 0. This is some. It can be what? Either 0 or 1. Listen here. S3, S2, S1, S0. Maybe added all zeros. Answer will be taken as it is. Okay. This is one case. Okay. S3 if it is less than 9. If it is result is greater than 9, what you do? S3, S2, S1, S0 go. You are adding 6. So in this first bit, 0 is added means S0 comes as it is. In this, no adder required. In this, no adder required. Is it okay? Next, listen here. You are adding these two. You will get sum and carry. You are adding only 2 bits here. So what is sufficient for you? Half adder. Now here you are adding 1 minute. Let me change the color so that it will be better. So here you are adding 3. So you will be getting sum and carry. But in this case, you need full adder. That is 2 half adders. Last stage, you are adding only these two. So again, you will get sum and carry. And this process required only half adder. So total how many required? Only 4 half adders because you are adding only 6 here. Okay, so it is 7 plus 4, which is 11. Okay. Thank you. Now, I think 1 hour is done. No, 2 into 4 minus 1, because here C naught is 0 na. For LSB you need half adder only. 2n minus 1 is the formula. Okay. Right, correct. Just give me 1 minute. One minute, please. Is there any wrong in the answer solution? Is there anything wrong in the solution? One minute. Now, okay, fine. Now listen. Yes, I write in left hand only. Okay. Any mistake is there? Anybody? Right. So only sometimes. What I want to say, yeah. So there is a possibility here. So I'm not satisfied with that 11 also. I'm not satisfied with that 11 also. To make some test series. Okay. I'm just giving you small. Auxiliary is not having any meaning here. You are having only one nibble. There is, what is the auxiliary? Auxiliary itself carry. If you have 8 bits, then that is, these are 4 4 and another 4 4 is there, then auxiliary will be coming. Okay. So here, let's try for full adder 1. You have the numbers A3, A2. Here it is in the range of 0 to 9 only. Okay. So here, if it is 1 0 0 1, here 1 0 0 1. Okay. This is for 9 1 0 0 0 1 0 0 0. Okay. So you understand here. No, not that case. Please, Asif. Okay. Not every time it is 8 and 9. It can be 9, it can be 7. Okay. It can be 7, it can be 4. All are possibilities. Okay. But I want to give you one hint to try like this. So if there is this 0 0 will never give any carry. Na? Okay. So from this, you try if there is any possibility to get no carry here and make it as a half adder. Okay, maximum answer is 18. 18 means what? So the carry will propagate here. Maximum answer will come when you are adding these two ones. In that case, carry will not appear here, but 1 plus 1 will give you some 0 carry. Input is having this number to this number and this number to this number. Because it is a BCD, input can be anything between 0 to 9, 0 to 9, anything. Is it clear what I'm saying? So now what I am thinking is you can get that is you can get this carry under three conditions. When your answer is 16, 17, 18, that is 8 plus 8, 8 plus 9, 9 plus 9. Three cases may carry equal to 1. Okay. Yeah, I am saying generalized. Please listen. There is a possibility of 7 and 7. Okay. 7 and 7 is possible. So sum is 0, carry is 1. Sum 0, carry 1. Sum 0, carry 1. So these two must be full adders. There is no doubt in it. These two must be full adders at any cost. This must be half adder at any cost. So for these three, you need not worry. For designing this, is there any possibility to make it with half adder? That I want to ask. You understand my question or not? In all combinations, you need to check, Aditya. You don't know. All the combinations you should check. As you are the designer. Okay. So try that. Is there any way so that I can reduce this one? This is I am giving as a homework. Half address on possibilities. Okay, let's continue. Okay, electrical. Those who attended yesterday can say. Rest for others. If you want, you can attend. Otherwise, your wish. Your wish. Up to only one day. Tomorrow. If you leave day after tomorrow onwards, again it is a common class for everyone. Tomorrow I'll finish that. I'll finish the subject syllabus of the EC also. Then who want to leave can leave. Bye. Bye bye. Remaining EC can stay. Thank you. Okay, we'll start. So remaining electrical people, tomorrow you are getting off now. So please try to revise the things, write some exams and all. Anyway, we will take some exam also on academy. You also try all the previous questions. We have done almost all questions. Okay, so let's start. So let's start the logic. So yesterday class we have discussed up to PMOS. We have discussed up to PMOS. I have given the conclusions of the PMOS also last part of the class. Now come to NMOS. NMOS. Okay. What is the NMOS technology? In NMOS technology, how to do it? We'll discuss it now. So here let's take logic 0. Logic 0 is equal to 0 volts. Logic 1 equal to plus VDD. Okay, positive logic only. So now let me design the inverter first. Okay, so this is the circuit. Okay, let me prove it as a inverter. So let's take when the input A equal to 0, that is 0 volts, or 1, that is VDD. What about the transistor Q1? If it is 0, 0 minus 0, what is the gate to source voltage? What is the gate to source voltage between 0 and 0 is 0. So transistor will be off. What about the output? If it is off, this VDD will come. This is him pull up resistor. Okay, this is a pull up. Okay, so you get after something, you will be getting the VDD at the source voltage. Subtract gate minus source. VDD minus 0. What is VDD minus 0? It is NMOS will be on mesh. NMOS inverter figure. Here for 1 it is on, for 0 it is off. For 1 it is on and for 0 it will be in off condition. So now let's do it. Let's implement the other gates also using this. We have very good questions in this. We'll discuss it. Uh, and now I already told this one it is on. Not, then only it will be short circuited. Both are short circuit. You will get 0 volts. If any one of them is off, you get a open circuit, that is 1. What is the gate? What is the gate here? Both are ones, then only 0. Otherwise, it is 1. Which one? Why nor here? Aditya, you forgot the truth table of NAND gate. It is NAND. Who is Nana? Who is Nana, man? Okay. So now, let's take one more. 0, 0, 0, Q1, Q2. When it is 0, it will be off. When it is any one of them is short, overall is short only. So if any one of them is short, overall is short. So you will get zeros here and 1 here. So this is an example of which gate? Now tell me. Yes, both are 0, then only 1. No. So let me give you the conclusion. Let me give you the conclusion. In NMOS is NAND. Parallel is NOR. Okay, so for PMOS, positive logic, series will be, sorry, NAND will be parallel, NOR will be series. Okay, just reverse. That is the dual to each other. Okay, PMOS and NMOS logics are dual to each other. Same circuit is replaced by an PMOS technology, then NAND gate will become NOR gate, NOR gate will become NAND. Okay, yesterday we discussed this now. Here series is NAND, there parallel is NAND. Here parallel is NOR, there series is. This discussion is done already yesterday. So now let's have few questions. Before that, let me give you specifications of. These are often not required to remember, but just to understand roughly what will be the values. In a ES kind of exams, they may ask you relative performance. For that you need other logic families also. These are some typical values of NMOS technology. Some questions. Of NMOS technology. Right. So now, write down the logical expression for y. Try to write the logical expression. Just comment it. Aditya, one small small mistake. Okay. So what is the simple blind rule is a series multiply parallel. Right, Hrithik? Correct answer. You should take whole bar. Okay. So what is the simple blind rule is a series multiply parallel add. Series multiply parallel add. Finally, you should take whole bar. Finally, you should take a whole bar. So what is your y? A into B plus C plus DE whole bar is the simplest way to write this. Okay. For any NAND, okay, or NOR, so in NAND or any case, inversion will come for free. Please keep that in your mind. Because for series, what is that? It is not DE, it is DE whole bar. We know this. Okay. Parallel, it is A plus B whole bar. So now you understand, actual NOR gate is not made like this. OR gate followed by inverter. Those are wrong. Not one more, take two more. Take two more. Okay. So now let me have one more question. TX is transistor. Our sister. See here, inverter is there now. Wait. I will tell you first some things. This is called load transistor. This is called driver transistor. Okay, I write transistor only. Okay, happy? Right? These are the names, the technical names. Right. Read it, I will start the phone. In NMOS inverter, charging time is always greater than discharging time. Is the reason for it. Aspect ratio of the load transistor more than driver. Aspect ratio of a driver is more than load. Charging times takes more time than discharging in general. Aspect ratio is width to length ratio of your semiconductor, what we call your MOSFET channel. In analog, you will be reading that. Okay, shall I start? Okay. So some 40% people give right answer. I will tell you now. Yeah, sorry. So Aditya, just wait. Listen here. Now listen. This is the inverter. Okay. Now for this you have connected some load. So load is having some capacitance. Okay. So this is let's say RL is on resistance of RD is on resistance of driver transistor. That is, when this is on, it will offer a resistance of RL. This will offer a resistance of RD. So when output is at logic 1, when output is equal to 1, okay, so this will act like RL and this will be charging this. This is off. Okay, this is when output is at 1, this part will be in off. So this is the circuit you will be having. So this is your charging. So what is the time constant of charging is RL into C. Next. Now, when the output is at 0, when the output is equal to 0, you will be having this also. Okay. So this is by default on only. If this is anytime, it is like a resistor. So now the capacitor will be discharging with this low resistance path. The capacitor will be discharging via this path. Okay. So now what happens? Okay, this will be discharging. Then What is the tau during the D? RD into C. RD into C. So to happen this properly, generally we can say, I will prove. I will explain that again. Now just examiner has given in any NMOS discharge. This is the design condition. Why it is there? I will prove it. I will tell you the reason behind that also. Don't worry about it. First, now listen here. It is also called aspect. I am also not to width to length. Driver should have more width aspect ratio than low resistance compared to your load. So now come back. Question. Aspect ratio of driver should be more compared to load. Is it clear? I will explain it now. What is the why RL is to be greater than RD? That point I will come to that. Firstly, as per question, charging should be greater than discharging is always greater than discharging will indicate tau C greater than tau D. RL should be greater than RD. If RL is greater than RD, definitely this should be greater than this. Because R is inversely proportional to width to length ratio. Okay. Now, why RL is greater than RD? I will come to that. Just listen first. This point is clear to you or not? Very good. Very good. So now, why this is happening? Because see here, I want this to discharge through this path. One simple way is in the steady state, if you replace this capacitor with open circuit, whatever the voltage present here will come here. So this resistance should be very low. Then only you get less drop here compared to this by voltage division principle. That is one way to explain it. Okay. Otherwise, see here, and the output transfer is in up to this only this part. Now listen here. When output is equal to 0, when output is equal to 0, this is plus VDD, RC, and sorry, why RC? RL and RC. Now I want output equal to, what is the output here? VDD into, these two are in series now. Assume there is no element here, for example, at least in the no load condition. RC by RL plus is very high compared to RC. RL should be more compared to RC, then only this is possible. Okay. Otherwise, see here, for example, RL equal to 1, RL equal to 10, RC equal to 10. You connect 5 volts here. You connect 10 and 10 here. You get the same 2.5. But you connect the same, it is almost equal to 0.45. So this is what required for us. That is this part and this part. Relatively, this should be low compared to this. Then when the output is at low, output is at 0. Even this is 10, okay. This should be 100. Understand? So that is what we require to make the output equal to 0. That's why generally in the design itself, when they make the design of the NMOS inverter, they will make such that the bottom resistor, bottom transistor will have more on resistance than the upper top resistor. That is the design. In the design itself, they will make it like that. Is it okay? So let me give you one more question. You can have any number. What is the problem? You can have. What is the issue? No problem. You can have. Image failed taking you back to class. Please tell me. Here, why image is not uploading? 1 minute, guys. Maybe I connect to different network. Don't. Okay, it is already connected. Yes, Avicha, you can do. I know my student only who has completed MTech in NIT and now he is doing in IIT. IIT Kanpur he is doing. Just a few days back only he called. Okay, now let's try to upload whether it will upload or not. Yeah, finally uploaded. First one I don't know. Second space. That is true, but there is an issue for that half header. What is that issue is what you said is correct, but you can go for that. I have given the answer. Okay, anyway, come to this question. Question. It is a 7 only. Okay. Otherwise, if in one particular case, I mean, I'm not saying you don't use in place of half header if you use XOR and AND gate, that is not correct. If you want to do something simple, one small modification, that is allowed. You can give that both the statements, not an issue. So please try this question, just leave that. For the circuit shown in the figure, rising edge triggered D flip flop is used with the synchronous reset as a clock frequency of 1 Hz. The NMOS transistor has an on resistance of 1000 ohms and off resistance of infinity, open circuit. The nature of the output waveform is. Please give a try. It's a good question. I like this question. It contains NMOS technology part is there, your op amp is there, your what is that flip flop is there. For this circuit, this is asynchronous reset means nothing but clear only. Okay, you have that clear. R means reset or clear, nothing to worry. Sorry, it is not visible. This is, let's zoom further. You take this plus minus. I have that figure. Let me cross check it. Yeah, correct one. Top one is plus, bottom is minus. Okay. So the time period of the clock is 1 second. What is this time period? 1 second. Okay. Right. Okay. So time period is 1 second. That is the clock time period will be equal to 1 second. So when the first positive edge occurs, D flip flop input is already 1. So this becomes 1, this becomes 0. This becomes 0 means this transistor will be off. Microampere and capacitor. Okay, so that you have a constant current flowing because it is open circuit now. It is open circuited. This part is open circuited. So what is your output? Output is equal to 1 by C integral 0 to t current in the capacitor I dt. I by C into t. What is I? 10 power minus 6. What is C? 2 into 10 power minus 6 into t. So what is that? 10 power minus 6 minus 6 is the same. Okay. It will charge up to how much voltage? Point. So your V naught is equal to 0.5 t. This must be equal to 0.1. Then t must be equal to, take this, 0.1 by 0.5, which is 0.2 linearly charged. This will be 0.2. Okay. So when this is greater than 0.1, what happens? 1 minute. That is what happened here. 1, this will become 0. Wait. When it is 1, it is reset. Na? Reset make Q becomes 0. This will become 1. When this is 1, the transistor will be on. Just wait, Ganesh. Let me finish the question, then you can understand. So the transistor is now on condition. Having a resistor of 1 mega ohm with initial 0.1, and you have some source also. What is that source? 10 power minus 6. Okay, this is the circuit now you are having. This is your output. Okay. So anyway, op-amp input current 0, you can neglect that part, nothing to worry. Now, what happens is, what is the R equivalent? 10 power 6. C equivalent 2 into, let me directly write the tau. What is tau? 1 minute, I think 1000 ohms is given like that. Yeah, 1000 ohms. I'm sorry. Ten power 3. So 2 into 10 power 3 into 10 power minus 6, which is 2 milliseconds. Relatively low compared to 1 second. So now you can understand discharging is the RC circuit part. Now please listen here. If you draw the waveform for 1 second, after 0.1 in 10 milliseconds. 10 milliseconds means how much? 0.01. Okay, so very fastly. Steady state V naught, you just replace this with open circuit, then you can do it. That is not an issue. V naught steady state will be equal to 10 power minus 6 into, so it will almost becomes like this, and it will come. Again, this story will be repeated after every 1 second, because 1 second ke baad kya, new clock comes. New clock comes immediately, again it will become 1, this will become 0, and the story will be repeated. You may have the doubt, when it discharges, this will again become 0, but reset is happening only when it is 1. After that, you remove it also, it will be at 1, or it will be at 0 only until you apply the next clock, because they are edge triggered. Once you give reset, it becomes 0. You remove the reset also, it is at 0 only until you apply the next clock. Okay, so what is the available options? Which one is suiting your requirement is almost like this. So linear charging, discharging. Linear charge and sometime is required to reach 1 second, then again charge, discharge. I love this question. So if it is okay, we can end the class for today. That almost when it is charging, there is no time, no resistance. Okay, there is no infinity now. So the capacitor will charge up to infinite as long as much as you keep it. It will linearly charge. It will reach infinite. Point where it reaches final value here. You can say it kind of. It is not a Bibo condition. So those please ask what is your doubt. Like this. Okay, you take it. What about this path? In that case, no op amp can charge. Op amp equivalent if you draw. This is the circuit. I'm inverting on all those things. Fine. So let's end the class for today. Thank you. Good night. Bye bye. Right. Thank you. Bye bye. Good night.